Welcome back to another MECH 1000 video. We're in Unit 9 in the Blueprint Reading textbook, and in this chapter we're looking at thread specifications. And I know this series of videos for this unit has been going on a little longer than most chapters, but this is a pretty important chapter. This thread specification is kind of a big concept to get our minds wrapped around, and we'll continue to see questions about threads throughout the rest of the semester, so it's important to spend some time on this. And I ended the previous video a little bit early because I wanted to be able to make sure I got all the way through this particular problem without being interrupted. So this question is asking how many full threads will the threaded portion contain? So this is the threaded portion. From here to here, we can see that the threads are being represented by the simple method of thread representation, just some dashed lines here. And we can see the note here says that it is 1 inch external diameter, and it's 8 UNC-2A. So that 8 is the TPI, the threads per inch. So all we need to find out then, we just need to take our 8 threads per inch and multiply it by however many inches this is long. The problem is that's not given. That is the missing link in our broken chain system of dimensions here. So what we're going to have to do is we're going to have to actually calculate what this is. We're going to have to take that overall length of 5.91, and we're going to have to subtract from it 1.625 and subtract 1.000 and subtract 0.25. And also subtract 1.562. So we calculate that, and let's see what we get. Okay, I got 1.473. So that means this is 1.473 inches long. So if we take 8 threads per inch and multiply it by 1.473 inches, the inches will cancel out, and that'll tell me how many threads we're left with. So we take that 1.473 multiplied by 8, I get 11.784, except the question asks for how many full threads are there. So we just round off that decimal, and we say we've got 11 full threads. Okay, what is the decimal equivalent of the surface roughness height? So this has been coming up in the past couple chapters of Blueprint Reading since it was introduced. And so this particular part of the test shaft is turned on a lathe, and we need to get it pretty smooth. And in fact, we've got this finish symbol, this checkmark symbol, indicating that it's been finished, and we have this number 32, indicating the allowable surface roughness height. The units of this surface roughness height are in millionths of an inch. So this is essentially asking what is 32 divided by a million. Okay, and so as a decimal, that is 32 divided by. All right, let's be careful when counting these zeros. It is 1, 2, 3, 4 zeros, so it's 1, 2, 3, 4 zeros, followed by a 3 and a 2. Okay. Something I don't think we have seen before is tabulated dimensions. I know when I worked as a structural engineer, we would often use dimension tables like this for footings. Rather than having to dimension every single isolated footing of a building, we would just label it footing as footing A, footing B, footing C. And then in a table elsewhere on the drawing, you could look up and see what the height, width, and depth of the footing is, and maybe also some information like what kind of rebar is inside that. So you can see the same type of tabulated dimensions for mechanical drawings as well. In this particular example, we have dimensions on a bolt, and they're just simply labeled A, B, C, D, and E. And so if you want to know what those dimensions are, then we need to look at what is the thread specification, A, and then we can see what the corresponding dimensions B, C, D, and E are. So it's a way that you can communicate a lot of information in a more effective way. Okay, the next thread idea is multiple threads. So these are kind of interesting. Basically, the way multiple threads work is, and I'm going to try my best to draw on here. Actually, maybe I'll just draw some parallel lines. So usually with threads, you would have one groove, one track, basically. If you traced this path with your finger or some type of instrument that would go along the groove, you would go through one groove and around the other side and then back through the next and around, and you just make like this corkscrew pattern. There's just one track going round and round and round and round. But you could have multiple threads. So you basically what you'd have is you'd have two sets of threads running parallel to each other, and depending on where the interlocking thread joined, it would go in one track or the other. And so with this, it would, like for instance, here, let me switch my pen color to try to describe this. There we go. So you might get into one track where you're going along here, except when you wrap around the backside and come up, you're not coming up into the next track, you skip one. That goes up and around and like so. And then I can switch my color again. So if your thread didn't start in this one track, it might have started in the other one, running parallel to it. So basically what happens when you have these multiple threads is that one revolution of the fastener is going to advance the fastener twice as far than it would have if it was just one thread. And actually, I guess in here, this is actually a triple. So there should really be three different colors, three different parallel tracks. And this one is the double. So it's just a way to use the same size thread, but allow for the advancement of the fastener to be 2 or 3 times as fast. Okay, let's move on to, I think we're getting close to the end here, pipe threads. So pipes are, they don't use typically or at all, the unified national thread form. That is really just for nuts and bolts and things like that. Pipes have their own thread form of, and there are a few different ones, but the NPT, the National Pipe Tapered, or NPS, National Pipe Straight, are the most common thread forms used. And as the name implies, NPT threads are tapered slightly. So an NPT would be a little more narrow at the end, got a slight taper to it, versus NPS, which does not. It would just be straight. And so here we have a chart showing us some of the sizes of pipe threads. Now, one thing about pipe is that it's typically dimensioned by its inside diameter. So if you have, let's say, 1-inch pipe, then the inside diameter is going to be 1 inch. We can see here that the outside diameter is considerably larger, and that's because of the wall thickness of the pipe. So the outside diameter of a 1-inch pipe, and that 1 inch is just nominal. It might be slightly different than 1 inch, but it's approximately 1 inch. But the outside diameter is 1.315, and that's where the threads would be on the pipe, the outside diameter. And then you can see the corresponding number of threads per inch. For a 1 inch, it's 11.5. Okay, so here we have an example of a thread form shaft illustrating a bunch of different types of threads, and they are shown, they're drawn in the very detailed, realistic type of representation of threads. How many of them contain multiple leads? Well, looks like here we've got a double and another double, and looks like that's it. So it's just 2 of them. Another type of threads that you would see on pipes are dry seal threads. This is just another form of threads, an alternative to NPS or NPT. They're abbreviated NPTF, NPSF, and NPSI. And the last thing to mention in this chapter is bar stock. So hex bar stock, you could purchase some hex bar stock and actually make your own hex head bolts if you wanted to. And so that might be the stock material used to make some of these threaded fasteners that we've been talking about. And I just want to point out here that when you talk about the size of hex stock, it is dimensioned across the flats. So in other words, if we got some 1-inch hex bar stock, that would be 1 inch in that direction, not 1 inch from corner to corner. So that dimension there would not be 1 inch. It's the flat to flat dimension that is the 1 inch. And that finally brings us to the end of this unit. I know this is a lot of information, but as I said, this is important information that we'll continue to see throughout the semester. Questions about threads and their number of threads and the pitch of the threads and the size of the threads and the class of fit and things like that will continue to pop up later in the semester. And in a future chapter, we will talk about metric threads, which are different in some ways. But that's for another chapter. So until then, if you have any questions, be sure to use the discussion board on Blackboard or speak up and ask those questions in class.